Hello everyone, welcome to the video solution for Edexcel Physics. This is IAL Physics January 2019 new specification WPH 11. So let's start. Question number 1. Which of the following is a vector quantity? A typical question generally comes in these types of paper where you need to distinguish between vector and scalar quantity, and if you have a list of scalar and vector, and if you memorize these two column as a scalar and vector, then these types of questions are quite easy to do. And you can see that all of these are scalar except the displacement, which is in the vector column. So displacement is a vector quantity. Your option is D. Question number 2. Which of the following is equivalent to 1 kilowatt hour? Okay, remember kilowatt hour, kWh. Sometime we write kWh. This is unit of energy, not power. That means our option D and B is immediately gone, because kilowatt hour is energy, not power, so it cannot be W. So it might be 0.28 joule and 3.6 times power 6 joule. But if you see that 1 kilowatt hour, so 1 kilowatt means 1000 watt, and hour means times hour, 1 hour. Converted this into second, so times 3600 second. And clearly if you solve this, so you have option 3.6 10 to the power 6 joule. So your option is C. Question number 3. Stokes law can be used to determine the frictional force on an object moving through a fluid. To which of following would Stokes law best apply? A large sphere moving quickly through a fluid. Remember, it's all about Stokes law application. So Stokes law can be applied only on a small sphere and should be smooth and moving slowly, in a laminar flow. These are some of the conditions that we assume to apply the Stokes law. So the large sphere is gone, a small sphere is fine, but moving quickly, due to quickly we cannot apply. A small sphere moving slowly, so your option is D. Question number 4. A force of 90 Newton is used to push a box along a ramp of length 10 meter up to a platform. The platform is 4 meter above the ground. The weight of the box is 200 Newton. Which of the following expression could be used to determine the efficiency of the ramp? So efficiency is all about the output divided by input. So in this case, when the person brought the box at the height, so the output would be in the form of gravitational potential energy, and this is our output, and the input would be the work done by the man on the box. So work done. So you can see that the man is applying force of 90 Newton to push the box along this ramp of 10 meter. So the output would be gravitational potential energy. So the mass of the weight of the box is 200 Newton and height covered is 4 meters. So output is GPE, which is 200 times 4. If you see, this is 2 Newton, mg, and h, divided by work done, and work done is 90 times 10, force into displacement. That means your option is C. Question number 5. According to third law of Newton, when two objects interact, they exert forces on each other. Which of the following statements is not a correct description of these forces? It's all about Newton's third law pair, and if you see, for two forces to be as a Newton third law pair, we have four properties that we need to look for. That both of the forces should be of the same type of forces, and they must have the same magnitude. They act in opposite direction, and they act on a different object. So if you see the option, the force act at the same time, indeed they should act at the same time. The forces act in the same direction. Now the direction should be opposite as per third point or third property of the Newton third law pair. So of course the option is B, which is not valid for Newton third law pair of forces. Question number 6. A ball is thrown vertically upward. Which row of the table correctly describe the magnitude of initial acceleration of the ball and the magnitude of the acceleration when it is at maximum height? So remember, when some object is moving under gravity, there always be acceleration due to gravity stays or act on the object. So no matter it is at the ground or at the some height or during the motion, so throughout, initial acceleration, when it starts, initial acceleration is 9.8 and it stays constant throughout the motion. So of course at maximum height it cannot be 0, so it should be 9.8 throughout. So option is C. There might be a confusion for some students that they think that at maximum height the object will be stopped for some moment, but remember, it's still in the gravitational field, so gravitational force is acting. That means acceleration is acting. So it is not 0, it is 9.81 meters per second square. Question number 7. One end of a 50 centimeter length of wire is attached to a support. A load is attached to the free end of the wire, which extends by 2 millimeter. Which of the following is the strain for the length of the wire? A strain is epsilon, which is change in length divided by original length, and the change in length is 2 millimeter. This is delta L, but remember the original length is given in centimeter, so we must have a change in length in centimeter divided by 10, so 0.2 divided by 50, and the now option is 0.004. This is your strain, so option is A. Question number 8. A ball is dropped, bounces once and is then caught. Which of the following graphs of gravitational potential energy against time could represent the motion of the ball? So if you see the situation, we cannot have option B and D, because in both of these options gravitational potential energy initially is increasing, but if you see that the ball is dropped, that means gravitational potential energy is decreased. So initially is decreased, after bouncing gravitational potential energy is increased. But if you see graph C, it seems a true graph, because gravitational potential energy is decreasing and then increasing. But if you see, when the object is dropped, the initial velocity is 0, and when it is coming down, falling down, the velocity keeps increasing. That means the rate of change of gravitational potential energy increases as it falls down. In graph C, the change in gravitational potential energy, the rate of change, see, rate of change means you find the gradient. Gradient means E grave divided by T. This is the rate of change of gravitational potential energy, which is constant throughout. That means gravitational potential energy is decreasing with a constant rate. But in reality, as velocity is increasing, the object is moving faster and faster and faster. So rate of change of gravitational potential energy is increases. That means if you see the graph, and the rate is basically the tangent, and at every point the tangent is increasing. That means steepness is increasing, so rate of change of gravitational potential energy increases during the drop, and then rate of change of gravitational potential energy decreases during upward motion. So your option should be A, not C. Question number 9, the stiffness constant and the Young modulus are terms used in physics. Which row of the table shows the correct application of these terms? A stiffness constant applies to and Young modulus applies to. So material, object and object. Okay, so your option is D. It is because the Young modulus is the term that we use for a material. It doesn't matter what the shape of the material is. That means if we say that the Young modulus of iron, that means it is constant for a given material or iron, whether it is in the form of wire or what. But here, stiffness or spring constant or K depends on the sample or the shape of the object. So option is D. Question number 10. A student used a balance to measure the mass of a small cube with the sides of length x. Okay, this is the cube of a length x, 50 gram of the mass. The student also measured the mass of the larger cube with the side of length 1.5 of x. Okay, same mass, then which of the following is the density rho L of the larger cube in terms of rho S of the smaller cube? So you just need to compare the densities of the two material. So for a smaller box, the density is rho S is m by x cube, mass over volume. I'm not using 50 here because mass are same. So 50, so I'm using m upon x cube, and the mass of the larger cube rho L is same mass upon the volume, and volume is 1.5 cube into x cube. This is the volume of the larger cube, and when you divide these two, so you do rho S divided by rho L, or it's rho L. So you do the ratio work, and then you say that m upon x cube divided by m upon 1.5 cube, and 1.5 cube is 3.375 x cube. So you can simplify this fraction, and finally you will get answer rho L is equal to 0.296 of rho S. That means you round this 0.296 as 0.3 because it is an option D. So rho L is 0.3 times of rho S, so option is D. Question number 11. The graph shows how the velocity of an object varies with time. So this is velocity and the time, and we have a graph. Describe how the acceleration of the object varies with time. Your answer should include a calculation. So if you see that initially from 0 to 5 and 7.5, okay, till here, this is 9 seconds. Okay, so from 0 to 9, the object is accelerating, and you can figure out the acceleration using some calculation. So you can do the calculation like in the first interval 0 to 9, your acceleration is positive, which is 10, 12 and 40. So 14 minus 0 divided by 9 minus 0. So y2 minus y1 upon x2 minus x1. So acceleration is 1.5 555 or 1.6. You can say the acceleration is 1.6 ms minus 2. This is the acceleration. So you can say that 0 to 9 the object or the object is accelerating, is speeding up, and after 9 to around 11.5, or you can say it's approximately 12. So 11 to 12 it is decelerating, slowing down, and if you wish you also can calculate the acceleration of the deceleration value here. So you can say that acceleration a dash is 14 and then 0, so minus 14 divided by the interval is, if I take it 12 minus 9, which is 3. So you can say that for around 4.6 meter s minus 2, this is the deceleration, and after reaching 12 second, it moves with the same rate but in opposite direction. So here velocity is 0, but the object does not stop. It reverse or change the direction and keep moving with the same rate of minus 4.6 meter per second in opposite direction. That's how you can explain, and I already showed you the calculation of 1.6 and minus 4.6. How did you get that? Question number 12. A student carries out an experiment to determine a value of, for g, the acceleration of free fall. A short wooden rod is released above a light gate. A timer connected to a light gate is used to measure the time taken for the wooden rod to pass through the light gate. The experiment arrangement is shown. So this is a wooden rod, light gate, timer, and so on. The student uses the equation v square equal to u square plus 2as, where u equal to 0, then graphical method. So state additional measurement to the student should take. The initial measurement is the student should know or should measure the length of the rod. It is important because the length of the rod is going to be used to find the velocity. So it's going to need the length of this rod and the height fallen. So height fallen of the rod. These two measurements are important. You can measure from the bottom or from the center of gravity. It's up to you. You will have to take measurement from the same point every time when you repeat the experiment. So height and the length. These are two additional measurements. Describe how the velocity v of the wooden rod is as it passes through the light gate can be determined. Yes, the length of the rod is divided by the time. So length of the rod is divided by the time. You can find the velocity of the rod as it passes through the light gate, and then you can repeat this experiment for several times or maybe 3 times to find the accurate velocity or average velocity. Describe how the student can determine a value for g using a graphical method. So first of all, you will have to record multiple value of reading or multiple value for v for different height. And then you will have to plot graph again v square against the height or the distance. So why I'm doing is v square against s, because the student is using the equation v square is equal to u square plus 2as, and u is 0, so v square is equal to 2as. And if you see that, if you need to find acceleration, the acceleration is half of v square upon s, and this v square upon s you can get from as a gradient of v square versus s graph. That's why we are plotting v square against s graph, and from that you will get a straight line, something like that, and then you can find the gradient will give you v square upon s, and then acceleration can be found by half of the gradient. That's how a student can find the acceleration using graphical method. Thank you very much for this video. I hope you enjoyed. Have a nice time.